Hello and welcome back to the Core Learning channel. Today we're going to be looking at functions. So a function is essentially a set of mathematical operations which we apply to some input to receive an output. You'll often see functions written as f of x or g of x or h of x, but there are also well-defined functions. These include sine of x, log of x, the modulus of x. Each of these in turns applies some transformation to this input x to produce an output. So let's take an example, the modulus of x. So the modulus of x simply says that for any value of x, we return the positive value of x. So for instance, if x was -1, the input -1 is transformed to be positive, and the output would therefore be 1. So we're just going to kind of look at the actual notation for functions. So let's imagine we've got this function here. So f of x equals x squared plus 2x plus 1. So let's just break this down quickly. So this first part, this f, this is just a mathematical notation. This just says we're dealing with a function. And as I said before, we can use f, which is the most common, but we can also use g and h. They're also common, but we can use any letter we want, essentially. The next part, inside the brackets, is the input variable. So this is going to be the thing that we change to produce different outputs. And lastly, we have this x squared plus 2x plus 1. This is essentially the transformer. This is the mathematical operation that the input goes through for the output to be created. So we're going to look at a few different types of questions that we can get when dealing with functions. So the first of these is going to be evaluating functions. So evaluating functions simply means that we get given a function and we get told what the value of x is. So we get told what our input is and we just have to work out what our output is. So we can see here we've got this example, which is f of x equals x squared plus 2x plus 1. So the first question might be f of 2. So this says what happens, or what is our output when our input is 2. So here we just replace every instance of x with 2 and carry out the transformation. So doing this, this would become 2 squared plus 2 times 2 plus 1, which gives 9. We do the same if we have 5, so we replace every instance of x with a 5, so we get 5 squared plus 2 times 5 plus 1, which equals 36. One more for good measure, we've done f of -1, so again we replace the x's with -1s, and this works out to be 0. So now you've seen a few examples of that, we'll jump straight into some practice questions. So question 1, we have given the function f of x equals x squared minus 5x plus 3. We want to find the following 3 values. So pause the video and have a go at those, and I'll shortly go through the answers. So let's jump right into the answers here. So for question 1, we're just going to replace every x with a 1. So we get 1 squared minus 5 times 1 plus 3. This gives us -1. f of 4, we'll replace every x with a 4. This again works out to be -1. And lastly, we have f of -2, which if we replace all x's with -2, we should get 17. So we'll try another question now. So this time we've got given the function g of y equals 2y squared plus 3y minus 1. Find these following values. So for the first one, we're going to substitute 0 in place of y. And when we do this, we get -1. When we substitute in 7, we're going to get 118. And when we substitute in -3, we're going to get 8. And the last question we have is h of x equals 2x cubed minus 10x. So we want to find h of 3, h of -2, and a h of 5. So for h of 3, we substitute in the 3 in place of x and we get 24. H of minus 2, we get 4. And h of 5, we get 200. So the next type of question we might have is combining functions. So this is where we take a function of a function. An example question might be, we have this function f of x equals x squared plus 2x. We have this other function g of x equals 3x. What is f of g of x? Or what is g of f of x? So this can be a little bit tricky to understand. So let's try and break this down a little bit using our example. So we have f of x equals x squared plus 2x and g of x equals 3x. And we first of all want to know what f of g of x is. So how would we go about doing this? Well, one thing I like to do first, I like to put the brackets around innermost function, so in this case the g of x, to make clear that we're going to be evaluating the outer function, which is f of x, with the value g of x. So remember before, we were evaluating some function, let's pretend it was f of x, and we might have evaluated it with the value 2. Well, in this case, we're evaluating it with the value g of x. Well, the value of g of x is 3x. So this is exactly the same principle as when we were evaluating functions. We evaluate the function f when the value is g of x, which is 3x. What this means is wherever we have an x in the function f of x, we're going to replace it with a 3x. So f of 3x is 3x squared plus 2 times 3x. And then we simplify, and that's it. So f of g of x is 9x squared plus 6x. And it's the same thing with g of f of x. It's exactly the same principle, just the other way round. So now we're evaluating the function g of x with f of x as the value, or the input. So we have our input f of x, which is x squared plus 2x, and we're evaluating it against g of x. So in this case, what this means is every time we have an x in this function g of x, we're going to replace it with a x squared plus 2x. So g of x squared plus 2x is 3 times x squared plus 2x. And again, we just simplify. And when we do this, this becomes 3x squared plus 6x. Hopefully that made sense. So let's do a practice question. Here we have the following two functions. We have f of x equals 2x squared, and we have g of x is equal to x plus 1. So have a look at these questions. We have 2, which are going to be actually combining the functions, and then 2, which are going to be evaluating. So pause the video and come back when you want to run through the answers. So the first thing I'm going to do is just write out my two functions, which are 2x squared and x plus 1. The next thing I need to do is I'm going to use my own rule, which is I'm going to put the brackets around the g of x, which makes it clear we're going to be evaluating the function f of x with the input g of x. So now to write this out, I have my f of g of x, and I'm going to write this out, and I'm going to put in the brackets, instead of g of x, I'm going to replace it with the value of g of x, this transformation if you will, which is x plus 1. So this says I'm evaluating this function f when the input is x plus 1. Now our value of f of x, if I write it out, oh, it's not x plus 1, is it? that is incorrect. Let me find the rubber and erase that. Nope, it is 2x squared. And I'm just going to put a bracket around this x. And what we're going to do when we want f of x plus 1 is we just replace the x with an x plus 1. And now all we have left to do is just tidy this up and simplify. So to do this, we can expand this bracket, which is going to give us x squared plus 2x plus 1, and this is all multiplied by that 2. And we could just tidy that up one more and simplify. Multiply through by 2 gives us 2x squared plus 4x plus 2. So we've got our answer to the previous part, which was fg of x equals 2x squared plus 4x plus 2. And we now want to evaluate this entire expression when the input is 4. So again, we're just going to replace these x's with 4's. And so we've got 2 times 4 squared plus 4 times 4 plus 2. And now we just need to work out what that is equal to. So this is going to be 2 times 16, so 4 squared, plus 16 plus 2. And when we simplify this, it gives us 32 plus 16 plus 2, which is equal to 50. So now we want to find g of f of x. So we're going to rewrite this with the brackets around the f of x, just to tell us that we are in fact evaluating the function g of x with the input f of x. So we're going to write this out. And then we've got our brackets next to the g of x. This tells us our input. So our input here is going to, no, actually it's not going to be x plus 1, is it? That is g of x, sorry. So the input is going to be f of x. So let's just redraw that. And this is our 2x squared. So we want to evaluate the function g of x when the value is 2x squared. So we know that this g of x is equal to x plus 1. I'm just going to write a bracket around the x. So we now just replace all these x's with 2x squared. And when we do this, this is fairly simple to simplify. This is just 2x squared plus 1. So now we want to evaluate this g of f of x when the input is 3. So we can just replace our x with 3 here. So this is 2 times 3 squared plus 1, which is going to be 2 times 9 plus 1, which is 19. So this time we've got two different functions here. We have g of x is equal to 2x plus 2 over 5, and h of x equals x squared plus 4. So for part A, we want to find g h of x. So as always, I'm going to do my first step, which is to just write this with the brackets around. So we're evaluating g of x with the input h of x. So hopefully you're starting to get the hang of this a little bit now. So we're going to substitute this value of h of x inside the function g of x. So we're going to evaluate g of x squared plus 4. So we know g of x equals 2x plus 2 over 5, and I'm just going to put a bracket around the x just to make it clear. And then we're just going to replace all our instances of x with x squared plus 4. And then all we have to do once we've done that is going to be to simplify. So we have this 2 times x squared plus 4, which is going to simplify to 2x squared plus 8. We have this plus 2, and then that is all over 5. And when we simplify this further, we're going to get 2x squared plus 10 over 5. So we now want to evaluate this when the input is 5. So we're just going to put a 5 in place of this x. So we get 2 times 5 squared plus 10 over 5. So 2 times 5 squared is 2 times 25 plus 10 over 5. And we just simplify, which is going to give us 50 plus 10 over 5, which is 60 over 5. And this is 12. So now we want to try and work out hg of x. So we're going to rewrite this with the brackets around the g of x. So this is evaluating h of x with the input g of x. So now we're going to put the actual value of g of x, which is that 2x plus 2 over 5. And this is now our input into the function h of x. So we're just going to put a bracket around the h of x here, the x in the h of x. So we're just going to replace any instance of x here with 2x plus 2 over 5. So we get this 2x plus 2 over 5 squared plus 4. And now we just need to simplify. So this squared term becomes 4x squared plus 4x plus 4. That's over 5. That's over 25 rather. And we have this plus 4 term. And just to make things simple, I'm going to write this plus 4 term as 100 over 25. So we now have the same denominator. So we can add the numerator terms together. So we get 4x squared plus 4x plus 104 over 25. So now that we've worked out hg of x, we want to evaluate this when the input is -1. So all we need to do here is just substitute every instance of x with this -1. So this is going to become 4 times -1 squared plus 4 times -1 plus 104 over 25. And now we just need to simplify this. So -1 squared is 1, so this is going to be 4 plus -4 plus 104 over 25. The 4 and the -4 cancel out, so we just get 104 over 25. So far we've been looking at a case where we have some input, we apply it to a function, then we get some output. Now, the reason we have inverse functions is when we ask the question, well, actually, I have the output, but how do I get back to the input? The way we do this is you apply an output to an inverse function transformation, and it should return the input. So let's take an example here. So let's look at Fahrenheit to degrees Celsius and the equation that governs this relationship. So the equation we've got here, we've got this F, and this is a value in Fahrenheit. And then we have this function F, or at least a mathematical notation for it. And this is going to convert a value in degrees Celsius to a value in degrees Fahrenheit. and we have this C, which is the value in degrees Celsius. And then we have this actual mathematical relationship that governs it, which is for any given Fahrenheit, for any given Celsius, we multiply it by 1.8 and then add 32, and this will give us the corresponding value in Fahrenheit. So we have this relationship, but now what if we ask the question, I now want a function where I can input a Fahrenheit and it will give me the value in degrees Celsius as an output. And this is where an inverse function can come in really useful. So we will shortly go over how to calculate the inverse function, but essentially the notation here, this f minus 1 of x generally, but here I've put of f, this is the notation. This is my inverse function of f. So here what we can see is my inverse function of f, when I evaluate it with a Fahrenheit, will now give me a value in degrees Celsius. So we'll look how to actually calculate this value now. So I'm writing out this function of Celsius, which is 1.8C plus 32. But now our desired output is going to be C. So I want to know what input to this function f returns C, or rather f of question mark equals C. Now let's write out this equation. So f is 1.8 and times this question mark plus 32 equals C. And we'll replace this question mark with a y. So we have 1.8y plus 32 equals C. And we now rearrange to find the value of y, which is C minus 32 over 1.8. Now this is our inverse function. So our inverse function here is C minus 32 over 1.8. And the way we write this is f to the power of minus 1 of C equals C minus 32 over 1.8. So we now have our two functions. We have our initial function, which took a value in degrees Celsius. It multiplied that value by 1.8 and added 32, and it outputted a value in degrees Fahrenheit. And we then just worked out the inverse function, which is C minus 32 over 1.8. So what I want to do now is I want to prove, and this is what I said before, I said if we have an inverse function and we apply the initial output, remember the initial output of our function was a value in degrees Fahrenheit. So we apply Fahrenheit, or a value in degrees Fahrenheit, to this inverse function. It should return C, or a value in degrees Celsius. So we're going to prove that now. So this inverse function is C minus 32 over 1.8. Now this C is obviously a variable. So when we're evaluating this function with f, this inverse function becomes f minus 32 over 1.8. Now we already know the value of f. We have it right at the top, in the top right hand corner. It's 1.8c plus 32. So what we're going to do is we're going to sub in that value where that f is. So we now have 1.8c plus 32 minus 32 over 1.8. And we can see that the 32's cancel out, and then we're left with 1.8c over 1.8, and the 1.8's cancel out, and this leaves us with just c. So we can see, in fact, that this does work. So more simply, when we have a function of Celsius which equals Fahrenheit, we then, if we take the inverse function, we can then apply a Fahrenheit to this inverse function, and it will return a value in degrees Celsius. So hopefully you understood all that and you're ready to have a go at a few questions. Pause the video and come back when you're ready to run through the answers. So we have our f of x, which equals 2x plus 2 over 5. And we want our output to be x. And what we're going to do is we want to find this value y, which we need to rearrange to find the value of y. So we move the 5 across, so we have 5x equals 2y plus 2. And then we have this 2y equals 5x minus 2, and we have y equals 5x minus 2 over 2. And so our f minus 1 of x equals 5x minus 2 over 2. So now we have our next function, which is g of x, which equals x squared plus 5. What we want to do is we want to find an output of x, and we're going to replace this x squared with a y squared. So now we just need to make y the subject. So I'm not going to go through this in great detail. I do have a rearranging formulas video if you want to check that out. But we're going to get that y is equal to the square root of x minus 5. So g minus 1 of x is root x minus 5. So part C, we have h of y, which equals 5y plus 3. So again, now we want to make y the subject, and we're going to replace this 5y plus 3 with a 5x plus 3. We want to rearrange to find this value of x. So just bearing in mind, this value that we replace, so this x in this case, it's just a placeholder. It doesn't hold any significance. You could choose any letter. In my explanation, I used a question mark. It really doesn't matter. But yeah, so we're going to get that this x equals y minus 3 over 5. And we're just going to replace this with a h minus 1 of y. So the inverse function of y equals y minus 3 over 5. So for this last one, we have f of z equals z squared plus 2z plus 1. So this is slightly trickier. So here, what we need to do is, first of all, obviously write this out in terms of our output z, and then we're going to convert these z values to y's. So we get z equals y squared plus 2y plus 1. And what we can do here is we can actually say that this quadratic expression is the result of y plus 1 squared. So now we can take the square root of both sides, and we get that the root of z equals y plus 1, which means y equals the root of z minus 1. And we can just replace this y with the f minus 1 of z. So our final inverse function is root z minus 1. Thanks for watching, guys. Hopefully you enjoyed the video and learnt something today. If anything is unclear or you have any questions, leave a comment and I'll get back to you as soon as possible. If you haven't already, please like and subscribe, and we'll see you at the next one.